Assalamu alaikum students. The topic of today is band theory of solids. As we know that the solids are divided into three main categories. Some of them are insulators, some of them are semiconductors and some are conductors. Now students, the conductors are actually the metals. They have more free electrons. In conductors there are more free electrons. And in semiconductors, why there are free electrons? Because in the outermost shell there must be 1, 2 or 3 electrons in the metals. And in and in semiconductor there are 4, 5, 3, 4, 5 valence electrons. Valence electrons means outermost shell of the semiconductor is filled with 3 electrons, 4 electrons or 5 electrons. And the valence band of the conductor has only 1, 2 or 3 electron. That's why it is very easy for a conductor to lose an electron, and it is not a difficult or not an easy task for a semiconductor to lose an electron, because it has 3, 4 or 5 electrons in its valence shell or in its last shell. Now coming back to the insulators, insulators have 6, 7 or 8 electrons in its valence shell. इसके valence shell में 6, 7, 8, it's almost filled, so it is very difficult to snatch an electron from an insulator. It's very easy to snatch an electron from a conductor. Now let us discuss their band theory. In insulator there is conduction band and valence band, and in between it there is wide forbidden gap. That wide forbidden gap has the energy of 6 electron volt. Now it is very difficult for an electron to jump from valence shell to conduction band. Now for a perfect transmission, perfect flow of electron, the electron must have to jump from valence band to conduction band. Now because there is a wide gap in between valence band and conduction band, so that is why it is not an easy task for an electron to jump from valence band to conduction band. That's why it is an insulator. It does not allow current to pass through it, or it does not allow heat to pass through it. So we can write that there are no charge carriers in insulator. So now it's very clear about the insulator. Now let us discuss about the semiconductor. In semiconductor, as we know that it has a narrow forbidden gap and it has the energy of 1 electron volt energy. So in it there are charge carriers. As we know that in insulator there are no charge carriers, but in semiconductor there are charge carriers, and the charge carriers are holes and electrons. So the charge carriers are in semiconductor holes and electrons. So as we have discussed that it has 3, 4 or 5 valence electrons, and it is not a perfect conductor nor it is an insulator. So that's why devices are designed through these semiconductors like germanium, silicon, because they are very good semiconductors. They allow some of the electricity to pass through it and they do not allow some of electricity, and thus semiconductor allow some of the charged particles to pass from valence band to conduction band. Now let us discuss about the conductors. Now the conduction band and valence band of these conductors are overlapped. In it, overlapping. So there is overlapping of valence band and conduction band, and if we apply any voltage source to it, the electrons move from valence band to conduction band. And in it the charge carriers are electrons. So there are charge carriers, and these charge carriers are electrons. Now let us talk about their valence band and conduction band. The valence band and conduction band of these conductors is full. So we will write that, sorry, let me rub it. Now let us revise the topics. As discussed, valence band and conduction band of the conductor is full. So we will write that its valence band and conduction band are full. Means electrons in the valence band and conduction band. And when we talk about the insulator, its conduction band is empty and its valence band is full. As we know that there is a wide gap between it, so it is not allowing electrons to flow from the valence band to conduction band. Now in semiconductor, valence band is partially full and conduction band is partially full. Now here if we discriminate between these all, so the second point is that it has 6 energy volt wide band gap, and semiconductor has 1 electron volt wide band gap, and there is no gap between CB and VB because these both overlap each other. So there is overlapping in conduction band and valence band. So now let us discuss about the bonds that are present in these techniques like insulator, semiconductor and conductor. So the bonding between the conductor is ionic bond. So there always forms ionic bond because in it there is a complete transfer of electron. As we know that the electrons are transferred from valence band to conduction band, so it has the resistivity of 10 raised to power minus 8 ohm per centimeter. Now the conductors are, the example of conductors are as we know that iron, aluminium, silver, gold. Okay, so as we know that the insulator examples are wood, plastic, and the semiconductor examples are silicon, germanium, arsenic. Okay, so now let us discuss about the insulator, that which bonding is in between the insulator. So there only has ionic bond. The formation only has ionic or covalent bond. Ionic or covalent bond. So there may be ionic or there may be covalent bond. So in semiconductors only there happens a covalent bonding. In covalent bonding, as we know that there is not a complete transfer of electron, but there is a mutual sharing of electrons, and in ionic there is a complete transfer of electron. So as we know that in conductor there is ionic bonding, in insulator there is ionic or covalent bonding, and in semiconductor there is only covalent bonding. And there in semiconductors the wide gap is of 1 electron volt, in insulator the wide gap is of 6 electron volt, and in conductor there is no gap. There is overlapping of conduction and valence band. And in conductor the valence band and conduction band are full. In insulator the conduction band is empty but the valence band is full. Because of the wide gap, electrons are not allowed to jump from the valence to conduction. And in semiconductor the valence band and conduction band both are partially filled. Thank you.